be using lasers, would be doing all kinds of stuff. Literally, this laser would be a laser that you would be measuring things with. So the whole idea of trig is to measure things that are impossible to measure with rulers, right? It's super hard to accurately measure a really tall tree with a ruler, right? But I can measure the distance between the base of the tree and the ground and then figure out what the angle is. And then I can use some trig. So my question here is, kind of remind us of what we were doing last class. We've got a ratio of 1 to 12. So if this distance is 12 and this distance is 1, how do I find this angle? Well, I've got the O and I've got the A. So I'm going to do tangent. Tangent. And I'm looking for the angle, so I put in that -1. And then it's O over A. So I just replace my numbers. Tangent, -1, and then O over A. And that's going to give me my angle measure, right? So we were looking for the angle, so we used that little -1, and we just multiplied. So over here in the calculator, hopefully everybody has a Desmo open or can open one fast. Remember, you've got to have everything in degrees, right? So degrees and radians, you have to put it in degrees. Then we want to go over here and go to functions. And we need our inverse tangent, that little -1, because we're looking for degrees. And then inside our parentheses, our opposite side divided by our adjacent side. And oops. 4.76. So this angle right here needs to be 4.76 degrees. So if I make a ramp for my house with a 9-degree slope, that's not going to pass inspection. It has to be smaller than a 4.76 degree slope. That's just one example of why you might need to know this. Okay. Like I said, we should be, if we were face-to-face and coronavirus wasn't a thing, we'd be face-to-face. We'd be measuring things with tape measures and lasers and all kinds of fun stuff. I'd be yelling at people to not let lasers shine in people's eyes. Sadly, that's not where we're at. So you're finishing up the notes? You need that?
Yeah, I did that.
Okay.
All right, I'm done.
Okay. So if I give you an angle, you've got an angle and you've got a side, we do something a little bit differently. We still have that so, ka, and toa, right? I've got an adjacent side, so I can use tangent. I've got an adjacent side, so I can use cosine. I cannot use sine because I don't have the O or the H, right? When you go to fill this in, you're going to do cosine of your angle. So the 63 always goes next to the cosine. And then you make a fraction out of the A and the H. So A is 40 and H is down here. If I do tangent, I do the same thing. The T stands for tangent of my angle. So next to that, you either need that -1 for inverse or you need the angle. So 63. And then I've got O over A, which is 40. So I just made a fraction out of that. Sometimes that O is kind of weird variable. So sometimes I put a Y in there and then I just replace the O with a Y. So now to solve these is the second big problem. We want to make these into ratios so we can cross multiply. So when we cross multiply here, we get H times cosine 63 equals 40. So I want to get that h by itself. So I need to divide by cosine 63. Divide by cosine of 63. This, my friends, is what goes in the calculator. And I know I didn't give you very much room. I apologize for that. So we're going to do 40 divided by, then I go over to my functions and I find cosine of 63. It's always good to close the parentheses. So my hypotenuse is 88 inches. That's the h. I know sometimes I like to go fast, so slow me down if you need me to, okay?
So you don't do
Going a little too fast.
Say it again, Mariah.
you don't do the -1, you just do the regular.
Correct. So I use the -1 if I'm looking for an angle, but here I'm given that angle. So I just use the 63 and you don't use the -1. So that's one of the changes for today. Over on this side, my math is a little bit easier. I don't have to do that weird divide by cosine of 63. I can just multiply. So 40 times tangent of 63 equals y. So then over my calculator, I just put in 40 times, and you can type in tangent if you want, or you can go to the function button and just put it in. And then 63. Make sure you're in degrees. So you want to make sure you're in degree mode. If you have it in radians, you're going to get some kind of weird decimal, 6.7. You need to be in degrees. And you should get 78.5. So this height is going to be 78.5. Karma, you were probably very confused about what we're doing and where we're at. We're kind of redoing in a different version what we did on Friday. So we're in this pair deck. We're on slide 4. We've really just started. Does everybody have that crazy chicken scratch? It will get more streamlined as we go and easier to follow. Slide 5 has all of your equations. So all we're going to do is substitute. We've got SO, CA, TOA. That's sine, opposite, hypotenuse. We put in our angle for the theta, so we don't need to use the -1. Or CA, C-A-H, is cosine of your angle again, and then A over H. And tangent, put in your 63 and O over A. So we still know SO, CA, TOA. We've just replaced the angle instead of having that -1. Okay, so let's see what this looks like. That's how we solve them. We would be doing it for real, but we can't. So maddening. Let me erase that little thing. So if we start here, we know our angle is 74. That's been given to us, right? And we know the opposite side. So we can make that adjacent side X if we want. And we'll make the hypotenuse H. So we're going to write SO, CA, TOA. And on your pair deck, I really do want you to write all of this. And we know the O, right? So we can replace an O, and we can replace an O. We can't use cosine because we don't have the A and the H. So we can't use that. So now we're going to substitute. The S stands for sine. So sine of my angle, which is 74. And then out of the O and the H, we make a ratio. So 10 over X. And then my tangent, right, is going to be tangent, again, of the angle, 74, equals O over A, which was X, right? A and X are the same thing. Oh, and this should be an H. So we got to cross multiply. Sine 74 times H. So H times sine of 74 equals 10. We got to get the H by itself. So we got to divide by the sine of 74. So H equals, and then we put this into the calculator, and that says sine of 74. So over here in my calculator, I'm going to delete all of this crazy chicken scratch, and we're going to do 10 divided by, and then I can go here and find my sine, and then my angle is 74 degrees. So what does that 10.4 represent? Okay, so we go to the calculator, right? And we're going to put in literally this 10 divided by sine of 74. So I go to my calculator, I put in 10. I just use like the backslash underneath the question mark next to the shift key to do divide, but you could just click on divide. And then you have some choices. You can either type in sine, or you can go to the function key down here and click on sine. And then you put in your angle, 74, and close the parentheses. Oh, you can't? Oh, let me see if I share my screen in a different way, if it helps. Can you see my Desmo now? Oh, sweet. So I'm going to do 10, and that just like the backslash. And then you can go down to functions and grab sine, or you can just type it in on your keyboard, and then 74 degrees. And you should get 10.4. So the hypotenuse is 10.4, this distance here. Okay.
Now I'm multitasking.
I'm going to warn you, you don't want to multitask and try to learn trig. Because if you learn it correctly the first time, it's crazy easy. But if you learn it wrong, it takes forever to fix it. So just word to the wise, you don't want to multitask. There are lots of things you can multitask with geometry. Trig is not one of them. So just be careful. So kind of like we did with the sine, we want to cross multiply because this is just really a fraction over 1. So we would get x times the tangent of 74 equals 10. But I got to get that x by itself, so I got to divide by tangent. So what I'm ultimately left with is x equals 10 divided by tangent of 74. When I have an x in the denominator, these two things just kind of switch places. These two things just kind of switch places. So I put this into my calculator now. So we're going to do the same thing, 10 divided by tangent 74. Oh, I didn't put my parentheses in. Oh, it didn't matter. Look at that. So now my x, this horizontal distance down here, is 2.87. So I've got an h of 10.4 and an adjacent side of 2.87. Without having to measure anything. I promise it will make more sense, but just like I told Elias, the only way for it to make more sense is if you do it with us. Okay? You really need to commit and invest in yourself to do the calculations and write down all the work, even though it's a pain in the neck with the Chromebooks. I wish there was a better equation editor or something. Can I go to slide 9, or is that going to freak somebody out? Okay, let's go to slide 9. So we've still got SOHCAHTOA. And I'm given the O. I'm going to make this X and this H. And I'm given the 61. So I spend the first minute of every problem just labeling what I know, kind of orienting myself. So if I have the O, I can do sine and I can do tangent. But again, I cannot do cosine because I don't have the adjacent and the hypotenuse. They're not given to me. So we write our equations out. Sine of 61 equals, and we make that into a fraction, O over H. And then tangent, the angle always goes next to that sine, cosine, or tangent, equals opposite. So 8 is my opposite over adjacent, and the X was my adjacent. Does that part make sense to everybody?
Yeah.
Yeah? Okay. Because I've got a variable in the denominator, these two things can just switch places. We can do all that crazy multiplying and dividing that we just did to prove that, or we can just remember. If your variable is in the denominator, you've got to switch your function and your variable. So I'm going to rewrite that. H equals 8 divided by sine of 61. Okay, all I did was switch places with the sine 61 and the H. And then you're going to put this in the calculator. So again, over in the calculator, you've got to be in degree mode. So make sure you're in degree mode over here. Super important. And then 8 divided by sine 61. Did everybody get 9.1? Okay, and that's my hypotenuse. So 9.1, and that was feet. That's this distance if I was measuring with a laser. It's the hypotenuse. And it makes sense that it's longer than the opposite side because it's opposite a bigger angle, right? I'm going to predict that my tangent, because this is going to be a 29-degree angle, this is going to be my smallest side. So when I do the math over here, X equals 8 divided by tangent of 61, that should be a smaller number than 8. So when I go to do that in my calculator, I need to do 8 divided by tangent 61, and I got 4.4. Did everybody get 4.4?
Yeah.
Good. And again, that's the ground distance. And that's opposite the 29 is the smallest side. So 4.4 is my ground, and 9.1 is my hypotenuse. And like most things in math, it's all about the patterns. And once you figure out the pattern of SOHCAHTOA, easy peasy lemon squeezy. Should we go to slide 10? Your back hurts or your brain hurts? Your hand? Yeah. Ariana, you're not alone. Lots of people will struggle for probably the first, like, even 6, 7 slides. And then once we get towards problem 10, it's going to start making sense. You're going to be like, oh my God, I got it. And then tomorrow, when we really do the practice, it'll be even better. So push through the struggle. Let's look at slide 10. Okay. Every problem is a new opportunity to master it. So I know 47. And this is the O. Elias, how you doing?
I'm doing good.
Yeah, I agree. I need a break from tests too. My tests and my honors geometry class are stressing me out. And if they're stressing me out, I know they're stressing the students out. Oh, me too. So we've got the O, so we're going to replace it in sine and tangent. Can we use cosine?
No.
We can't. We don't have the adjacent and we don't have the hypotenuse, so we can't use cosine. So we're just going to cross that out. You can only use what you can substitute in. So we're going to do sine always of the angle, that's our pattern, equals O over H. So that becomes a fraction. It's like sine of the angle equals O over H. That OH just forms a fraction. So the opposite side is the 40. And the hypotenuse is one of the things I'm looking for. And we can set up the tangent too. So tangent, always the angle next to it, unless you're looking for the angle. And then O over A turns into a fraction as well. So O is still 40. And I made A X, right? These two things are the same. What do I have to do if the variable's in the denominator? Switch them. Absolutely. So we're just going to rewrite that. H equals 40 divided by sine 47. And we're going to switch these guys here. X equals 40 divided by tangent 47. And then what do I put in the calculator? My ringtone? Uh-huh. So put 40 divided by sine of 47 in your calculator and see what you get. I predict it is going to be bigger than 40 because I'm finding the hypotenuse, and the hypotenuse is always going to be the longest side. So in the calculator, it should be bigger than 40. If it's not bigger than 40, then we need to relook at it. Ariana, can you join Zoom on another device? That might help. Oh, sad face. This is definitely the problem with virtual learning. So what did we get when we did sine, or 40 divided by sine 47? 54.7. 54.7 is the H for sure. And then what'd you get for the adjacent side? And I'm going to predict that that is going to be really close to 40, but a little bit smaller because it is opposite the smallest side. So 40 divided by tangent 47. Anybody get an answer? Absolutely. 37.3. 37.3 is that ground distance. And that kind of makes sense because 47 and 43, this is almost an isosceles triangle. So these numbers, the legs of the right triangle should be super similar, right? Oh, yeah, degrees makes all the difference in the world. So on slide 11, the rules change a little bit because I give you some different things, or at least one different thing. So we're still going to start with marking our angle, marking what we know. We're still going to start by doing so, ka, and toa. But we're given A this time. So I can put my A in for this one, and I can put my A in for this one. So which function can I not use? So can't use this guy because I don't have the opposite. I don't have the O, and I don't have the H. So remember, O is kind of a weird variable. It kind of looks like a 0, so I get confused sometimes. I'm going to change that to a Y. So then we just substitute. So the C means cosine. The angle always goes next to the function if you have an angle. And then A over H just turns into A, which is 12 over H. Same thing for tangent. So the T stands for tangent. It's just a little math shortcut. Tangent of the angle, angle always follows the function, and then we make a fraction out of O over A. So the O is the Y, and the A was the 12. So just like in the last three, we've got a variable in the denominator, so what do we have to do? Flip them? If the variable's in the denominator, you ultimately divide. So variable in the denominator, you're going to ultimately divide. So you want to put this part in the calculator. 12 divided by cosine, oh, not 12, 31. What am I thinking? I have a stylus and a touch screen. Is the answer to that? Yeah. You can also type them. Sometimes typing is faster than writing, especially with the mouse or the mouse pad. Oh, see, that's good feedback. Nobody had ever told me that before. So Elias, you got a new phone even from your repaired one? Wow. Elias, what did you upgrade to? Wow. That's crazy. So what did we get when we did 12 divided by cosine 31? How long is the hypotenuse? Mm-hmm. Or can I round it to 14? Because 13.9996, that's pretty close to 14. So what about the other one? How do I do this? If the y is in the numerator, I can just multiply. So y equals 12 times tangent 31. And it kind of makes sense that it's smaller than 12. Because it's opposite the smallest angle. Does that make sense? I'm not hearing very much feedback, guys. I want you guys to try 12. So what can I do now?
You gotta fill in the
Mm-hmm. So I know the 15. I'm going to fill in the A's, which means I can eliminate which function. Mm-hmm. Going to get rid of sine. So we've got cosine 15 equals what fraction? Mm-hmm. And then I've got tangent. And what's the fraction for tangent? Mm-hmm. So that's going to be O over A. So my O side is this side. That's the Y. And then the adjacent side is the 12. So what does H equal? Absolutely. So we've got to switch those. 12 over cosine of 15. We put that in the calculator. And then we've got y equals, and what do I do with the y? Perfect. So then over in our calculator, ooh, so which, I got 3.2 as well. Is that the hypotenuse or the height?
Hypotenuse.
Which one's the longest side?
Yeah.
The hypotenuse has to be the longest side. So the 3.2 has to be the height. So what's the hypotenuse? 12.2. 12.4. I agree. Is it starting to come together now? So we've done like 6 or 7 of them? I can't remember whether we have one more like this or whether it changes again. Are we ready to go look at slide 13? So slide 13 does change a little bit. How does it change? It does give you the hypotenuse. So here we're given the H, and we need the O, and we need the A, right? So, this time we've got the H, so we can put in our H, and we can put in our H. So which function are we not going to use? Absolutely. So we're going to get rid of that one. And we're going to plug in everything exactly the way we did before. We've got sine of our angle. The angle always goes next to the function. Equals O. So for the O, we made that a Y. And the H is 16. Is it are we gonna multiply or divide if we have a number in the denominator? We're gonna multiply. So Y is gonna equal 16 times the sine of 45. We can do that before we go on. 16 times the sine. So what do you get? So did I. So the height of our triangle is 11.3. So then we can come over to cosine, right? Cosine, again, of the angle equals, this time we want the A, so that's X, over H, which is still 16. We still have a number in the denominator, so we can multiply. So x equals 16 times, ooh, that should be cosine. Cosine 45. You do get the same answer. And if we realize that this is an isosceles triangle, 45 and 45, that means the x and the y have to be the same as well. So 11.3. Ta-da! Is my mic weird? I wonder if my connection is unstable. I'm sorry. I'm the one freaking people out. I promise I'm not talking weird. I have what kind of voice, Thomas?
I hear your red voice, then I hear like two other robot voices at the same time.
Hold on, I'm gonna record it for you. Say something.
Hello, my name is Mrs. Doherty.
It went away? Are you serious?
Are you serious? Whoa.
Maybe it'll be on the Screencastify video when I look at that. When I upload it for the rest of the class, that I don't even know where they are. I really expected more people to join us. They probably think we went back to the old schedule and didn't keep this schedule. Yeah, I think that's definitely what it is. So talk me through this one. How do I do it? What do I need to write?
So you put the 0 at 83, and you're going to, you're not, so, wait, you're going to do 2 of them, which would be sine and cosine, right?
Mm-hmm.
You're not going to do cos, you don't have the height.
Right.
And then for, so you're going to figure out like the O and the A, right?
Mm-hmm.
Doesn't matter which one you try to figure out first?
It doesn't. Nope. We've just been doing the first one first because I work left to right.
Okay.
And that O kind of looks weird. That's why sometimes I change that to a Y.
So then you're going to do
You are, sweetie. So I'm going to stop sharing for a minute just so I can let everybody into the class. Miss George wanted to keep the same schedule. So we've been in class since 10:15. So we talked about a bunch of stuff, and I'll just kind of get you guys caught up because you and Ethan just came in together. I put the Pear Deck slides that we're working on. We're already on slide 14. So I'll work with everybody on 14, 15, and 16. Wow, this phone is just ringing off the hook today. And then we'll work backwards with the people who come in late. Okay, Ashley, so I'll get you caught up.
I'm sorry.
You're all good. You're all good. So we're gonna work for another couple of minutes, and then we'll kind of go back. Okay. So you need 2 things open: the Pear Deck and Desmos. And you'll kind of.
It says that you ended the session with the Pear Deck.
Oh, did I give you the wrong Pear Deck? Maybe I did.
You're the one that's using inverse Trig.
We are in a new one. So let me put this in the chat. If it'll let me open the chat. There we go.
Okay, I'm in.
The one that's in the chat box, does that one work? It looks like this.
Yes.
Okay.
Yes, that one works.
And you want to go down to the one that has an angle of 83 degrees. So it's the third one from the end.
That one.
Okay. Did you find it? So here we're given an angle here, and we're given a side here. So we've changed kind of what we've been given since Friday. So we always put the angle next to the function, and then we set up the fraction the same way we did before. If there's a number in the denominator, you're just going to multiply. So this is going to end up being y equals 3 times the sine of 83.
I got 2.9.
So let me see. 3 times. I just made that my O side. Is it? I'm sure it's my connection. I started my computer this morning downstairs, and then I moved upstairs, and for whatever reason, our Wi-Fi doesn't work as well upstairs. That's crazy sounding. So this is going to be 2.97.
Wait, so you want to change it to 3.0?
I would not, and this is why. Because I've got a hypotenuse of 3, and that has to be my biggest number. Because this is almost a flat triangle, that angle is almost 90 degrees. It means this angle is 7 degrees. It means this is almost going to be 3, but it can't actually be 3 because it has to be shorter. Does that make sense? Normally I would say yes, round that to 3, but you can't have a triangle with a height of 3 and a diagonal of 3. It's just a really tall, skinny triangle. And we'll see that when we do cosine to find the adjacent side. So we're going to do cosine of 83 equals, and then the adjacent side over the hypotenuse, which is 3. And then you're going to cross multiply there. So A, it's not going to be the same thing this time. Because that one is opposite the 7-degree angle. This is going to be a super, super tiny side. It's going to be a decimal. So what do we get when we do 3? 2.9 is for sure the height. The height of the triangle is 2.97. And I'm sorry this is such a messy slide. 0.36. That is perfect. Okay. Lots of people are saying I sound like a robot. I think it's my connection, not yours. Or maybe it's everybody's connection and we're just having a weird day. So let's go to slide 15 and see if we can bring everybody up to speed. Elif, do you have access to the Pear Deck in the chat, or do I need to send it again? I'm going to send it to you anyway. So we're looking for something different here, right? Than we were on Friday, for those who have just joined us. I'm giving you an angle, and I'm giving you a side. We have the hypotenuse. We're looking for the O, and we're looking for the A. So we need to write our 3 things up here. So, Ka and Toa. Because we have the H, We can use cosine and we can use sine, but we can't use tangent. So then you're just going to fill in the stuff that you know. We've got sine of the angle, which is 62. The angle always goes next to the function. And then we make a fraction out of O over H. So the O is what we're looking for, and the H is what we're given. It kind of looks weird to have a variable O there, so a lot of times I rewrite that as a variable. It's the height of my triangle, so I'm going to make that Y, just to make it easier to look at. This is kind of like a proportion. 10-15. So I'll talk about that when we're done, so I can let everybody else go, and then I'll catch you guys up. So we're going to cross multiply. So y equals 12 times the sine of 62. And then you put this in the calculator. Make sure it's in degree mode. It has to be in degree mode. And what do you get? $10.6. And if we're not sure, because I hear some question in your voice, again, we're looking for the opposite side, right? That's going to be the bigger angle of the two, because this is going to be 28. So it makes sense that it's close to 12, but a little bit less. I think 10.6 is a super reasonable answer for that side. So we come over to the other side, and we'll do cosine. So cosine is 62. And we're going to do A over H. So A over H. I love it when I'm given the hypotenuse because you always multiply when you have the hypotenuse. So A equals 12 times cosine of 62. It is 100% easier because the hypotenuse is always in the denominator. So you always multiply. There's no need to do that weird flipping thing. $5.6, I think, again, sounds super reasonable because it's opposite that small side. So it should definitely be the smallest answer. Yay! Should we go to the last question? Do I need to wait for anybody? I know. I'm going to try to have better Wi-Fi tomorrow. I forgot about the extender. I got to plug that back in and log into that. It's been so long since I tried to work from home. All right, last slide. And then we're done for the day, and you don't have to hear my crazy voice anymore.
So you have to put 0, that's 25. And then use 5. Right?
Mm-hmm.
And then you're going to do A over 55.
O over 55. So sine is the opposite.
Yeah.
Mm-hmm.
So it's going to be 20, no. So it's going to be 55 times 25.
Perfect.
And then it's going to be 22.
And that makes sense because that's a very acute angle. So it should be a lot less than that 55. And let me see if I can write that a little more legibly. So I use sine for opposite and hypotenuse. What do I use for adjacent and hypotenuse?
You're going to use cosine to 25 equals A over 55.
And do I multiply or divide?
Yes, A equals 55 cosine 25. You say it's smaller, right?
I think it should be bigger because the 23 was opposite the 25. So this is going to be opposite 65. So it's going to be between 23 and 55.
Okay, I got 49. Well, 49.
I like it.
Yeah.
I think that's perfect. Yep. So the whole point of learning trig is to be able to measure things that you otherwise couldn't measure. So NASA uses this. Believe it or not, your cell phone uses this. The way GPS works is triangulation from satellites. And the triangulation works with trig. Some really smart people program in all this trig so it just runs in the apps on your cell phone and you don't have to worry about it. But somebody had to program it. Mm-hmm. There are 18 major satellites that support GPS around the world. And at any given time, your cell phone is connecting to between 3, 4, and 8 or 9 of them. And it uses all of those to figure out an average of where you are. We are done now. So I'm going to stop sharing for a second just so that we can regroup now that we've got most of the students here. Class does start at 10:15. So class is going to be from 10:15 to 11:35. If we need to do some kind of advisory thing, we'll do it at the 11:35 mark, or it's like 11:20 now. So if this was a normal class and had something advisory for you, that would be when I would do it. So the only thing I have is there are 1, 2, 3, 4, 5 people that have not picked up their materials bags. I was not allowed to leave them at the school yesterday. I have them in my possession. And in about 20 minutes, I'm going to get in my car and I'm going to start driving them around to people's houses. So you know you don't have your materials bag. You know I have it. Can I deliver it to the address that I have delivered to in the past, or are you staying somewhere different? If you are staying somewhere different, I need you to put that address privately in the chat for me. Okay? I think I have successfully delivered to all 5 of you, and I'm happy to bring them today. But I just need to know, because I know my second block, there were 2 addresses that needed to be updated. So if you are not somewhere where I know where you are, I need to know where that is. Okay? Otherwise, tomorrow, I will see you at 10:15. We are going to go into breakout rooms, and you're going to do more trig tomorrow, but with a group. Okay? You can pick your groups as always. And if you want to work by yourself, I'll put you in a group with a bunch of solo players. And you guys can just work independently in a group together. So when you have questions, I can come in and everybody can benefit from the answers. Okay? If you came in late and you have no idea what we were doing, hang out for a little while. We'll talk for 20, 25 minutes, and then I'll go on my Santa delivery room. But if you are done and you have completed all of the slides, you can peace out, and I will see you tomorrow. 12:40. And the schedule is posted in Schoology. You can find it there. It's a red and blue schedule. Okay. See you, Sterling. See you, Mariah. Bye, Elias. I'm sure you are very confused. It is rough to come into the last like 10 minutes of a class and be expected to kind of jump in. So, do you have access to the Pear Deck, the three of you?
Yeah, I do.
The Google Slides, and that's fine. Whichever, they're exactly the same problem. So if you prefer the Google Slides, I'm 100% down with that. I'm going to share my screen. Although, you know what I need to do? Well, I can do that. And what we can do is run through this backwards, if you think that would be helpful, or we can run through it forward. So I changed it. It's